Hey guys, welcome back to Algebra 2. Today we're going to look at problem set 53, which we have two topics. They're not related, but the first topic we're going to deal with some unit conversions. We've done a lot of this already, converting units of measure from feet to miles or something like that, but we're going to throw in the metric system today, and some of the problems we're going to have to jump from metric system to the English system or vice versa. We'll also include some of the square units and cubic units as well. But let's start with this first example. Using unit multipliers to convert on problem A, 32 yards to kilometers. Okay. One thing that you should remember, you should have done a lot of this in Algebra 1, but one thing you should know, one of the main conversions that we have to go from the English system, which is the inches, yards, feet, miles, into the metric system, the only crossover point that we know for sure is inches and centimeters. And you should remember that 1 inch equals 2.54 centimeters. You need to know that. If you don't have that memorized by now, you need to get that memorized. Okay, but 32 yards to kilometers. Okay, just like all the unit multiplier problems, we're going to start with our 32 yards, and I'm going to make that a fraction over 1, and I'm going to multiply that by a unit multiplier that will cancel the yards but change the units to something else. Now we need to kind of think of our game plan here to go from yards to kilometers. Yards is English system, kilometers is metric. So somewhere I need to get down to inches so I can cross over to centimeters. So my basic game plan is I want to go yards down to feet, and then I'm going to jump to inches. Now I can cross over to centimeters, and you need to know your metric system. To go from centimeters to kilometers, I have to jump through meters, then I can finish with kilometers. So that's my game plan here. I'm going to have several unit multipliers, but my first step is I want to convert yards to feet. So I have yards, I want yards to cancel, so they go on the bottom and turn into feet. And what's the connection with feet and yards? You should know 3 feet equals 1 yard. Next, feet need to cancel, so they go on the bottom, and I'm turning them into inches. Again, the relationship with inches and feet you should know is 12 inches equals 1 foot. Now we can cross over to the metric system. I want inches to cancel and turn into centimeters. Well, we just mentioned down here at the very beginning, 1 inch equals 2.54 centimeters. And now we need to go to meters. So centimeters need to cancel, and meters. Hopefully you remember the metric system. Centimeters are pretty small. It takes 100 centimeters to equal 1 meter. And now that we have meters, we want meters to cancel. And we're going to go to kilometers, which was our finishing point. And kilometers are pretty big. 1 kilometer is equal to 1,000 meters. Okay? That right there is converting 32 yards to kilometers. Now we can write these a little simpler, making this one big fraction, multiply the things together across the top. 32 times 3 times 12 times 2.54. I can leave off the ones because multiplying by 1 doesn't change anything. On the bottom I have several ones until I get over to the 100 centimeters and 1,000 meters. Okay, my final units on this was kilometers. So this is my simplified answer. Now you don't have to multiply it out and divide it all out to a big decimal or a big number. Just write it like this and that's good enough. Okay, let's try another one. This time we're going to convert some square units. We have square kilometers and we want to go to square miles. Okay, converting square units. I believe we've done some of these already, and what I suggest you do is start with just converting kilometers to miles. We'll throw on the squared part in just a minute, but we're going to start with this 0.063 kilometers. I'm trying to get those down to miles. Well, kilometers is metric, miles is English, so I needed to use that crossover from inches and centimeters. So my first step is I want to get kilometers down to centimeters. So here we go. Kilometers need to cancel, and we're going to meters. 1 kilometer is 1,000 meters. Now I need meters to cancel. Go to centimeters. 100 centimeters equals 1 meter. Now centimeters need to cancel, and I want to go to inches. Well, 1 inch equals 2.54 centimeters. We got 2 more steps. We need to go inches to feet. So inches cancel, go to feet. 1 foot is equal to 12 inches. And my last step, to get to miles, feet need to cancel, go to miles, and 1 mile is equal to 5,280 feet. Okay, the steps that I've shown you right here is how we would convert regular kilometers to regular miles. The difference on this problem is we were dealing with square units to square units. So this kilometers is really squared. Now, the only change that we need to make is take each one of these unit multipliers and we need to square it. So put parentheses around each one and square each one. The other thing you could do is copy down each one twice. I prefer to put parentheses and a little 2. Okay, now with this we could simplify this just like we did the one above and write it as one big fraction. One thing you should notice is this first number, this 0.063, that is the only number not being squared in this whole problem. So we have 0.063 times 1,000 squared times 100 squared times 1 times 1 times 1. Don't need those. Over. On the bottom I have a 2.54 squared and a 12 squared and a 5,280 squared. And my final units were miles squared. So there's my simplified answer. Okay, so hopefully this is some review. I'm quite certain you did this in Algebra 1 because I've done it with my Algebra 1 classes. So this should be a lot of review for this part of the lesson. Okay, the second part of the lesson, let's take a look. We're dealing with weight combination by percent. Now we've done some chemical formula problems where we have some chemical formula like this example CCl4. And we looked at finding what is the weight of some part of that given the total weight of the compound. Today we're just going to look at the weight by percent. Okay, so the first example here, what percent by weight of CCl4 is just the carbon? Okay, so we want to know what percent of that element or compound is the carbon. Well, it starts off the same way. We need to look at this little chemical formula, and we have some carbon and we have some chlorine. I need to know how many of each that we have. And you should remember the little subscripted numbers tell you how many atoms of that element. So the carbon, we have 1. The chlorine, we have 4. Now we started off those other problems in a previous lesson the same way. Now we need to take these times their weight. And the problems that you're going to see, they're going to give you those weights. The carbon is weighted 12. The chlorine is weighted 35. Okay, so we start this the same way. I'm going to start with a little table. And this last row, I'm going to label it total. Okay, so the weight of the carbon, I have 1 atom of carbon times 12 is 12. 4 times 35 is 140. And that totals to be 152. Okay, now we want to know what percent of the total weight is just the carbon. Well, out of this column here, 12, 140, and 152, the carbon is 12, the total is 152. So the carbon, to turn that into a percent, that's 12 grams out of 152 grams. So 12 out of 152. If I were to divide that, I gotta pull out my cheat sheet, 12 12 divided by 152 is 0.0789. Close enough. Now, that's the decimal form, and I just need to simply turn that into a percent. So to do that, I move the decimal over 2 places, and I get 7.89%. So, that's the weight by percent for the carbon. It's 7.89% of the total weight. All right, we could do the same for the chlorine, just to check to make sure we did it right. It's 142 grams out of 152. When you divide that, you get 0.921. Turn that into a percent by moving the decimal over 2 places. That's 92.1%. Okay, that's the only 2 things we have in there. So one way to check to see that you did it right, if you add these together, you should get 100. Now you might be off slightly due to rounding, but it should be pretty darn close to 100%. And 7.89, if you rounded that to 1 decimal place, 7.9 plus 92.1, that's going to equal 100. Okay, so let's try another one. Maybe this one will make sense. We have what percent by weight of potassium chlorate is the potassium? Chemical formula for potassium chlorate is KClO3. I'm sorry, KClO3. So we start off the same way. We're going to make this little table. K, we have some potassium, we have some chlorine, and we have some oxygen. And we need to look at how many of each we have. Potassium, out of this little formula, we have 1. Chlorine, we have 1. And oxygen, we have 3. So again, we're going to multiply these by their weights. Potassium, the weight is 39. Chlorine, the weight is 35. And oxygen, the weight is 16. So, here goes our table. Really, I just need one big column. Label this last row total. So, potassium, I have 1 atom times 39 grams is 39. 1 times 35 is 35. 3 times 16 is 48. And if I add that up, I got a total of 122. Okay, no matter which one they want to know the weight by percent for, we're still going to set up the same table. In this problem, we want to know the weight by percent for potassium. So just the K. So I take that 39. It's 39 grams out of the total 122, and we simply divide that. 39 divided by 122 is 0.3197, and I turn that into a percent by moving the decimal over 2 places, so I get 31.97%. I would suggest that you make those percents maybe to 2 decimal places. You could get away with 1, but 2 I think is a good practice to do. So the potassium is 31.97% of the total. Okay? Hopefully that's simple enough. One thing you could do on these tables, if you understand the percent tables that we've done on other word problems, one thing you could do is, like on this first example, if we use this second column and say that's our percent column, the total is going to be our 100%. And whichever one they're looking for, in this case the carbon, we could make that our variable. And you could set up your little proportion and cross multiply, if that helps. But I think it's just as easy just to take whichever one you want and divide it by the total and get the decimal and move the decimal over. If you use the table with the percent column, you won't have to worry about moving the decimal over. So something to think about. If you have questions on what I just said, ask me in class. I'll be glad to work an example either way. Okay, we've got 2 more examples for you to try on your own on this type. So maybe try one using the percent column and one without. See which way you like better. And just be sure to ask me some questions. Okay, this is lesson 53. Good luck.